When we draw an angle on the unit circle, the terminal ray of that angle intersects the unit circle at a point. In the last section, we learned that the relationship between an angle and the terminal point of a ray when it intersects with the unit circle can be defined as the cosine of that angle and the sine of that angle. These relationships are really what mathematics, in particular functional mathematics, are all about. These two functions, the cosine of t and the sine of t, are functions of t. They're what happens when you plug t into this relation. In this section, we're going to learn about 4 more functions that are related to these first two. These are the tangent, the cotangent, the secant, and the cosecant. We already know something about the sine and the cosine. We'll start by reminding ourselves that the sine is the name of the function, and if you want to indicate that you are using the function to take the sine, for example, of an angle t, then you can use this abbreviation. Remember that you're only supposed to use the abbreviation if you're actually taking the sine of something. The cosine can be abbreviated COS, but again, cosine of something. The abbreviation for tangent is tan. The abbreviation for cotangent is COT. For secant, we use SEC. And you might be noticing a pattern here. All we're doing is taking the first 3 letters of the actual name of the function, and that gives us our abbreviation. The problem with using that trick for cosecant is that we've already used COS for cosine. So here we're going to use CSC. I can also remember from the previous section that the sine of t is y, and the cosine of t is x. And what that really means is that together, the cosine and the sine, the x and the y, make up a coordinate pair, like this. This is really just x comma y for some point on the unit circle. But we've defined x to be cosine of t and y to be the sine of t, so these can be defined this way. The other 4 functions are defined based on these first 2. So if the sine of t is equal to y and the cosine of t is equal to x, the tangent of t is equal to y over x. You could interpret this as being sine of t over cosine of t. If you happen to know the coordinates, then this version of this identity is probably easier to use. And if you happen to know the angle and you can find its sine and its cosine, then this one might be easier to use. They're equivalent. They're just a little bit different looking. Those are what I consider the primary trigonometric functions, the sine, the cosine, and the tangent. The other 3 are defined based on the first 3 in this specific way. The cotangent is 1 over the tangent of t. The secant is 1 over the cosine of t. And the cosecant is 1 over the sine of t. Now, since the tangent is y over x, the cotangent being 1 over tangent is x over y. Since the secant is 1 over the cosine is x, the secant is 1 over x. And since sine is y, sine of t is y, the cosecant is 1 over sine, so that's 1 over y. These are in a slightly different order than they're presented in your textbook, and that's kind of for a reason. The way I learned these was to write them kind of in a horseshoe shape. So let me show you what I mean by that. If we write the sine of t, and then the cosine of t, and then the tangent of t, and then we go over here, and we write the cotangent of t, and then the secant of t, and then the cosecant of t, then this function is 1 over this function. This function is 1 over this function, and this function is 1 over this function. We get that direct relationship if we write them in the form sine, cosine, tangent, and then backwards, or upside down, I guess, cotangent, secant, and cosecant. This is just a mnemonic. It's a memory aid that I have always used. Feel free to use it or not, but I find it quite helpful. I'm going to move this little chart over here, and I'm going to make myself a new unit circle. Put some axes in. I'm going to draw an angle. I think I want to use this angle here. This is the angle 5 pi over 3. About here is 1 pi over 3. Pi over 3, or 60 degrees, is about here. A second copy of that takes us over to here. That's 2 pi over 3. A third copy gives us 3 pi over 3, or 1 pi, which is pi. That's 180 degrees. So there's 3 pi over 3. Another 60 degrees gives us 4 pi over 3, and here is 5 pi over 3. My goal in this particular activity is going to be to find the sine, the cosine, the secant, tangent, the cotangent, and the cosecant of 5 pi over 3. It's going to be a tight squeeze, but I think I can do it. All right, well, let's start with the sine of 5 pi over 3. The reference angle is the same size as this angle here, the one that refers back to the x-axis. So the reference angle is just going to be pi over 3. We know that the cosine and sine of pi over 3 are 1/2 and the square root of 3 over 2. We know that from our earlier work in this section, and our work in the previous section. So that means that the coordinates of 5 pi over 3 are also going to be 1/2, comma, the square root of 3 over 2. But let's check the coordinates of this point, because we have to get there by going to the right and then down. Our x-coordinate will be positive, but our y-coordinate will be negative. So it's 1/2, comma, negative the square root of 3. So from that, we can write that the cosine is 1/2, and the sine of that angle is negative root 3 over 2. The tangent is defined as being y over x, or sine over cosine, or y over x. So it's literally just going to be, I'm going to do this in some scratch space right here. Y over x would be negative the square root of 3 over 2 over, that's the y value, right? Sine is y, so that's the y value, divided by the x value, divided by 1 over 2. That gives me the square root of 3 over 2 negative. That's divided by 1/2, so times 2 over 1, which gives me negative the square root of 3. So the tangent is negative the square root of 3. It's a very tight fit here. Let's see if we can move this over a little bit. Sometimes I struggle to actually get this to work. Okay. Not sure that's much better. There we go. Now, since we've defined, I'm going to start with the cosecant here. We've defined the cosecant of an angle t, as being 1 over the sine of t. Since we know the sine of t is this value here, we just need to figure out what is 1 over that value, and we'll have our cosecant. So let's go in here where I was doing my scratch work, and I'll erase this scratch work, and I'll do what is 1 over negative the square root of 3 over 2. Now 1 is 1 over 1, so I can write that like that. And so 1 over 1 divided by negative root 3 over 2 is 1 over 1 times negative 2 over root 3. So here I'm going to get negative 2 over root 3. When I take 1 over this value, I get this value, negative 2 over root 3. And so that is my cosecant value, negative 2 over root 3. Now, as you can see, the result is just that I flip this over. So that's the algebra that goes with it, but I'm really just flipping this value over to get this value. So I can do the same thing with secant. The secant is 1 over the cosine. I know the cosine. If I flip this over, I get 2 over 1, or 2. Right? The cotangent is just 1 over the tangent. So if I know the tangent, I can just flip it over. I might need to think of this as root 3 over 1, and it's negative, so I'm going to get negative 1 over root 3. And just like that, we have not just the sine, cosine, and tangent values, but the cotangent, secant, and cosecant values of this angle here. And as a reminder, the angle I'm looking at here is actually this angle here, right? This really big angle here. But because of reference angles, I can just find the values of this angle, which let me find the values for this angle, and then check the sines. The sines here are a little bit different for 5 pi over 3 than they were for pi over 3, specifically in that since I'm in quadrant 4, my y-coordinate has to be negative. But other than that, I just found the x and y coordinate, the cosine and the sine, for pi over 3, checked my sines, my SIGN sines, and then once I had sine and cosine, I had y and x, I could find y over x, 1 over that, and 1 over each of these as well. And that was it. That's me. I found all 6 trigonometric, the values of all 6 trigonometric functions at the input value, the angle of 5 pi over 3, really just by finding 2 of them. One last thing to point out here is that there's a way to, another way to sort of memorize all these important values here, and that is in a table. Like if you know what the sine and the cosine are, then you can write down the values for these special angles, 0, pi over 6, pi over 4, pi over 2, pi over 3 rather, and pi over 2, and then find the sine, cosine, tangent, secant, and cosecant of all of them by writing them down in a table. Here's the table your textbook provides. But notice that I don't think we really need this, because if you know sine and cosine, then tangent is just sine over cosine. It's y over x. So 1 over 2 divided by root 3 over 2 is going to be 1 over root 3. And of course, if you rationalize the denominator, you get this version. But that's equivalent to 1 over the square root of 3. So you don't have to rationalize the denominator. This has also been rationalized, which is why it looks like it does. So it has this one, and this one, and this one, and this one. They've all been rationalized. So they look a little different than they would in a table that I made for myself, because I wouldn't bother doing that. The other thing that I would do differently is I would put them in the order sine, cosine, tangent, cotangent, secant, cosecant. The fact that your book has put them in this order is just down to the fact that that's how they introduced the functions. They wanted cosine to be equated with x. We tend to think of x as coming first, and then sine as being associated with y. We think of y as coming second. Tangent is defined as being sine over cosine, which is y over x. And then they introduce these other 3 in this order. So I would do my table very differently, and I invite you to do the same. Create a table for yourself that makes sense. You can use a format like this, or you can go do the first 3 and then make a separate table and go back up the other way so that you have your secant, cosecant, and cotangent as being related to tangent, cosine, and sine in that they're the reciprocals of those. Well, again, the video is longer than I intended for it to be, so I'm going to leave it at that, and we'll talk more about this table and what the best way is to remember these values in class.